This is practice test 5, and we're working on problem number 8. And the problem states that the average student score on a final exam over the past 15 years in a certain math class has been 80 with a standard deviation of 4 points. The current class of 25 students scored an average of 82, slightly higher, and the teacher wants to determine if the average score of the current class is different from the average score from the previous years. Use the 0.05 level of significance. I've labeled some of the numbers given to us. The 80 is the population mean over the last 15 years. The 25 is the sample size of the current class, and the 82 is the sample mean, the x-bar of the current class. The 4 here is the standard deviation of the population. And letter A, we're asked to construct a null and a research hypothesis. The null hypothesis always states that there is no difference. In this case, no difference between the sample mean of the current class and the population mean of the last 15 years. The research hypothesis always states that there is a difference, and so they're not the same. The sample mean of the current class is not equal to the population mean over the last 15 years. Now, in letter B, I'm asking you to draw a normal distribution curve with rejection and non-rejection regions based on alpha equal to 0.05 level of significance. And so what I am asking you to do is to draw the normal curve, and the population mean of 80 would be right in the middle. At this level of significance, the z-scores, as we've seen a number of times before, the z is equal to 1.96 on this side of the mean, and then minus 1.96 on the left-hand side of the mean. Now we're going to calculate the z-stat in a moment, and if the z-stat falls anywhere between these two z-scores, this is the non-rejection region, which means we do not reject the null hypothesis. If the z-score falls to the right of 1.96, we would reject it. This is a rejection region. And if it falls to the left, then this is a rejection region as well, and we would reject the null hypothesis. So this is what I want you to draw on letter B. For letter C, we want to state our decision rule, which is that we're going to reject the null hypothesis if the z-stat is less than minus 1.96, which means it's in this region here, or if the z-stat is greater than 1.96, which means it's in this region here. Otherwise, we fail to reject the null hypothesis. And then letter D, we're going to calculate the z-stat. And you have the formula given for the calculation of the z-stat. It's the x-bar, the sample mean 82 from the current class, minus the population mean 80 over the last 15 years, divided by the sigma of 4 over the square root of 25. And so we're going to get 2 in the numerator, and 4 over the square root of 25 is 5. When we do this calculation, we end up with 2.5 for our z-stat. Now that z-stat of 2.5 puts us out here in the rejection region. So when we come to letter E, state your decision and why with your conclusion. We're going to reject the null hypothesis since the z-stat is equal to 2.5, which is greater than 1.96. And since we reject the null hypothesis, we know there's a difference. We can conclude that there is a difference between the current class and the scores over the last 15 years. So we conclude that the current class has an average that is different from the classes over the last 15 years.